Hi, my name is Taryn Buechler, and I'm going to be presenting my demonstrative speech. This is my audience. Most of you are probably well aware that DNA evidence is now one of the primary methods used in convicting felons of certain crimes in court cases. However, unless you are normally up to speed on the new innovative research in DNA evidence, I'm assuming the vast majority of you are fairly uninformed when it comes to the various processes and procedures that are conducted in DNA testing laboratories. I'll start off by discussing the basics, such as what DNA even is. DNA, short for deoxyribonucleic acid, is essentially the building block of all life. It is responsible for not only your biological development, but also how you function. DNA is found in all living organisms, and with the help of advancing technology, qualified scientists can generate a new DNA profile for any living organism, which is where DNA evidence in court cases comes into play. The biological material that can be used to determine a DNA profile include blood, semen, saliva, urine, feces, hair, teeth, bone, tissue, and cells. The professionals or investigators of a crime are ultimately responsible for first collecting items that could have been touched or worn by a suspect involved in a crime, the main ones being clothing, hats, weapons, hairbrushes, etc. As technology continues to advance, forensic scientists are having an increasingly easier time making the most of small DNA fragments, such as a few mere skin cells left behind on the weapon, or even the skin or bruise of the victim who may have been beaten. It proves crucial that this biological evidence is found, collected, and preserved in the correct way, as heat and other factors have been found to degrade and damage the DNA samples. DNA testing must be conducted in a controlled laboratory with specific facilities and equipment that meet the QAS requirements. This is a very meticulous process that requires a great deal of patience and skill. To identify who the biological material came from, the unknown samples are collected and then compared to known samples taken directly from a suspect or victim. The primary method used in determining the DNA from which the crime scene is called restriction fragment length polymorphism technique, which is essentially comparing an individual's known DNA sample with a sample of DNA found at the crime scene. Every DNA sample taken into the laboratory undergoes the same process, which can then further be divided into 6 chronological steps. The first one, extraction, is the releasing of DNA from the cell. And then this picture is just showing one of the forensic scientists extracting DNA from the cell. Then a few basic steps for extraction. You first break the cell open to expose DNA. You remove the membrane lipids by adding detergent, and then you precipitate the DNA with an alcohol, which is usually ethanol or isopropanol. And since DNA is insoluble in these alcohols, it will usually aggregate together, giving a pellet upon centrifugation. The next process is called quantitation, which is determining how much DNA you have. And then this just gives a few of the main methods used, the main ones being UV spectrophotometry and the gel electrophoresis. The next one is called amplification, which is typically used if you complete the prior quantitation process and don't have an adequate amount of DNA. So the amplification process produces multiple copies of the DNA in order to further characterize it. The separation aspect is the process of separating amplified DNA product to allow further identification. And analysis and interpretation is the process of quantitatively and qualitatively comparing DNA evidence samples to known DNA profiles. And then last but not least, quality assurance is the process of reviewing analyst reports for technical accuracy. Each of these steps is equally as critical as the next, and even one slight mistake can result in that piece of DNA evidence having to be thrown out of the case. The DNA analysis process that was just discussed provides scientists with a chart called an electropherogram, which displays the genetic material that is present at each loci that was tested. A loci is just a particular position or place, if you were unaware. In the complete profile, each suspect tested will show either 1 or 2 peaks or alleles at each loci. In case you're unfamiliar with the term, an allele is just a variant form of a gene. Loci that display only one allele indicate that the person inherited the same marker from both parents at this specific locus. Where two alleles are shown, the individual inherited two different markers. The use of an electropherogram has proved to be a huge help to forensic scientists who are performing these various experiments and trying to identify the perpetrator. So far, these various processes discussed that are used in DNA evidence testing may seem fairly fundamental and straightforward, but these scientists often run into numerous complications, first and foremost being that pieces of DNA evidence often contain mixtures of DNA from more than one person. This can obviously be problematic as these samples are incredibly then difficult to analyze, separate, and eventually interpret. To allow profiles to be searched on a national level or database, the FBI created the National DNA Index System, which allows law enforcement throughout the nation to share any DNA profiles to further help in investigations and cases. These DNA databases contain DNA profiles from convicted offenders, arrestees, convicted unknowns, missing persons, and even biological relatives of the missing persons. As of 2012, there have been over 10 million DNA profiles in the system. With the help of rapid advancing technology in these various procedures and processes discussed, conviction and imprisonment of innocent persons in court has decreased significantly and will hopefully continue to wane as DNA technology continues to evolve and improve.